All right, so now we're going to take what we know about operations on integers and whole numbers and translate that to operations on fractions. So as a quick review, let's look first at what are the operations I'm talking about. And in this case, I'm talking about the four basic add, subtract, multiply, and divide operations. Now, these work or are applied in roughly the same way as they are with integers and whole numbers, except sometimes, and for certain fractions, we have to be careful when we're adding and subtracting with unlike denominators. So first, let's start with multiply, then divide, and then we'll talk about add and subtract. So let's look at the arbitrary case. Suppose I have a fraction a over b, and I want to multiply that to another fraction c over d. This just means multiply across the numerator, a times c, and multiply across the denominator, b times d. So an example for that, 1/2 times 3/4, multiply across the numerator, 3, 1 times 3 is 3, multiply across the denominator, 2 times 4 is 8, 1/2 times 3/4 is 3/8. Let's look at division now. Same fraction or same arbitrary case, meaning a over b represents all rational numbers or fractions we could be talking about, divided by c over d. Now, when it's written in this form, you can think of it in terms of a over b. We want to turn it into multiplication, and we're going to flip the denominator. We're going to take the reciprocal of the thing we're dividing by. And so I reverse to say d over c. Multiply across now a times d over b times c. Let's do an example in this case. I'll use the same values, 1/2 divided by 3/4. So I'm going to take the first fraction as it was, and then I'm going to turn the whole problem into multiplication by flipping the denominator or flipping the number we're dividing by. So that's 4 over 3. And now multiply across, 4 times 1 is 4, 2 times 3 is 6, and automatically look to see if I can reduce. And I can. 4 divides by 2, leaving a 2, and 6 divides by 2, leaving a 3. And so my final result is 2/3. So I'm going to repeat this division problem because it can be given to you in a different way, and I just want to make sure, in an abundance of clarity, to make sure that it makes sense to you in both versions. So notice I wrote a over b divided by c over d, and I used the division symbol. Well, we don't always use the division symbol. In fact, we almost never use the division symbol once you get into the algebra levels. So we actually use the division bar. So a over b divided by c over d. And I like to use a double bar when I'm doing fractions because it's clear where the division is. So again, rule is exactly the same. It just is being presented to you differently. We're going to take the numerator, because remember the first number represents the numerator, and we're going to just write it the way it is and turn it into a multiplication problem by taking the reciprocal of the denominator. So d over c, which would give you a times d, b times c. And to do the same problem again, that would be this problem presented this way. You'd take the numerator times reciprocal of the denominator. 4 times 1 is 4. 2 times 3 is 6, and we already know how to do that reduction. Final answer is 2/3. So in this case, the work you do is exactly the same, right? This work is exactly the same as this work. The only difference is it's presented to you in a different way, and so you apply the same rule in both cases. All right, so let's do an addition and subtraction problem, and I'm going to start with the easiest type. They look like this, a over b, to make it arbitrary, not equals, a over b plus Now this time I'm not going to write C over D because sometimes you're lucky enough to get denominators that are exactly the same size. So I'm going to say we have a fraction A over B plus another fraction where the numerator may or may not be different, but the denominator is exactly the same. In this case, all you have to do is add the numerators together, keeping the denominator that you had, and you get, well, there's no way to write that simpler. So let's look at that sort of in the arbitrary or in the exact form. Again, using the exact same numbers, 1/2. Well, I can't use the exact same numbers, right, because I have a different denominator. So let's say 1/2 plus 3/2. I have exactly the same denominator. What I'm actually looking at is, suppose I buy a pizza, I cut it into 2 equal pieces, and I eat one of them. And then I grab another pizza from the stack, and I eat 3/2. That means I take one pizza, I divide it into 2 equal pieces, and I eat 2 of them. And then I have to buy another pizza, cut it into 2 equal pieces, and eat 1/2. So 3/2 is really the same as a whole pizza plus 1/2 of a pizza. But how many halves have I actually eaten? So I can figure out how much pizza I've eaten. Well, I've eaten the 1/2 here, plus I've eaten 2/2, plus I've eaten 1 more half. And that means I can take, using my rule, I can take the same denominator and add 1 plus 2 plus 1. Just like eating pizza, I eat 1 piece, then I eat 2 pieces, then I eat 1 piece. And so that's 4 total pieces, and I can reduce that to 2 pizzas. And if you look at the diagram, that sort of makes sense, doesn't it? I could have, instead of buying a third pizza and eaten half, I could have just gone ahead and eaten the other half of the first pizza, which would have been 2 total pizzas, meaning this half of a pizza is exactly the same size as this half of the pizza. So pictorially, that's what you're dealing with when you have the same size denominator. So we can just do a little bit of arithmetic. 1 plus 3 in the numerators, you add the numerators, and the denominator stays. 3 plus 1 is 4, and then reduce 4 divided by 2 equals 2. And by the way, exactly the same thing happens if I do subtraction. 1/2 take away 3/2. Well, I have the same denominator, so I can just carry that forward. 1 take away 3 equals -2 in the numerator, 2 in the denominator. -1 is the result of 1/2 take away 3/2. All of that is doing fractions using the operations that we learned on integers, and we run into no real glitches doing our work, even though we have to take into account we're dealing with a special kind of number, of fraction. And so multiplying, dividing, and adding and subtraction all have their own little sort of method that has to go with it. It's still just the same thing as working with integers. Where we run into trouble is when we're asking or when we're wanting to do the same work, only now we want to do addition and subtraction when there are not similar denominators. So this pink one, notice B was in the denominator of both cases. Let's go back to this arbitrary form. A over B times, plus, that's what I meant, got a little lost, C over D. Now, we don't have the same size pizza slices. We don't know how big a pizza slice B is, but we know it's not the same thing as D. So we have to do something here to make the two denominators, to make the sizes of the pizzas exactly the same. And what we're going to do is we're going to multiply both of these by something over something, which is just 1, and something over something, which is just 1, so that we can change the denominator. The goal here is to change the denominator so they're expressed in the same size or the same value. So I know these little question marks aren't necessarily very mathy, but I find that it's easier to understand finding a common denominator when we use actual numbers rather than letters. And so I'm going to go ahead and do an example up here rather than just depend on the arbitrary form to make sense to us. So let's do this one. Let's go back to our original. We're going to take 1/2 times 3/4. Now, 1/2 plus, for some reason I want to do multiplication. We all would rather do multiplication than addition when it comes to fractions, but once you get the hang of them, they're actually pretty fun and they're not so scary. So the problem here is that our pizza has 2 different sizes. You're asking what happens when I buy a pizza and eat half of it, plus I buy another pizza, cut it into 4 pieces, and eat 3 of those. How much pizza have I really eaten? Now, of course, we could always say that this is 1/2 plus, well, we can't. I was thinking we ate the whole pizza, and then we could say it was 1 plus 3/4, but that's not true. It's 1/2 plus 3/4. So what we really want to do is find a way to say the same denominator size in both cases. So I'm going to keep 1/4 exactly the same. So we cut a pizza into 4 equal pieces and eat 3. But notice this one that's been cut into 1/2. If I can cut that into 4 equal pieces, then it's easy to see that 1/2 is exactly the same thing as 2 1/4 or 2/4. So this becomes 2/4 plus 3/4, and now it's just a simple common denominator problem. So we don't want to be going around drawing pizzas all the time. Well, let's go ahead and do this one. So this would be 1/2 plus this would be 2/4. 1/2 is the same thing as 2/4 plus 3/4, and that equals 2 plus 3/4, which equals 1 or 5/4. So we ate 5/4 of a pizza, meaning we ate more than one pizza. 4 of the fourths would be a whole pizza plus 1/4 more. So let's do one now that doesn't involve drawing a pizza. This time let's take 1/3 and we're going to subtract from that 2/5. In order to get the same denominator, I have to use multiplication. What I really want to do is I want to convert 1/3 to some number that has a denominator I pick, and I want to convert 2/5 to a number that has exactly the same denominator I pick. The tricky part here is figuring out which denominator. In this case, the common denominator, the lowest common denominator, is 15. I'm not going to show you right now how I got there. The next problem is going to go into greater detail about finding the lowest common denominator. But just to show you how this works, I'm going to tell you that the lowest denominator that's common to both of these problems would be 15. So you have to ask yourself, what did I have to multiply 3 by to get 15? Well, I had to multiply 3 times 5, and that's a legal thing to do as long as I also multiply the numerator times 5. So 3 times 5 is 15, 1 times 5 is 5. So I can rewrite 1/3 as 5/15. Now what about the 2/5? Well, what did I multiply 5 by to get 15? 5 times 3. Which is allowed as long as I also multiply the numerator by 3. 2 times 3 is 6. So now I've rewritten the first fraction with 15 in the denominator, and I've rewritten the second fraction with 15 in the denominator. And now it's just a simple add and subtract like over here. 5 minus 6 over 15, and that equals -1 over 15. -1/15. All right, let's do another one now where finding the common denominator is not so easy. So I'm going to give you a little algorithm to do that with. So let's take 3/6. No, that's not a good choice. Let's take 1/6, and we're going to add to that 2/15. Now, Last time I just multiplied 6 into the numerator and denominator on this side, and then 15 into the numerator and denominator on this side. But if I do that, that means I'm going to have to multiply 6 times 15 to find a common denominator. A common denominator. But we don't want a common denominator because later on we're going to have to reduce the fraction and take out all the extra parts. We want the lowest common denominator. So let's figure out how to find the lowest common denominator. First thing you want to do, step 1, is we're going to write the denominators that you have in as a product of primes. So we want to pop the denominators, pop the d's. So that's 1 over, we only care about popping the d's. We'd pop the numerators too if we wanted to reduce, which of course we would do, but in this case you can't reduce either of these. So 6 written as a product of primes is 2 times 3 plus 2 over 15 written as a product of primes is 3 times 5. Now see how they both have a 3 in them? Finding the lowest common denominator using the method I'm about to show you, finding the lowest common denominator means that if I multiply 6 times 5 like over here, that means at some point I'm going to have to include this 3 times 3, which is 9, and I'm going to get a number 9 times bigger than I need to work with. Much more likely I'll make mistakes, and much less likely I'll be successful after doing the multiplication and then doing the reductions. So let's get rid of that 9 right off the bat and make it a 3 instead of a 9. So here's the steps. Listen to the words I say because it's super important. All factors of the first denominator. What that means is we're going to write 2 times 3 down, all of them. Whatever that is, we're going to just write them down. And then 3, the next step, is only what I need, only new factors. I'm going to say the rest because you don't always have a problem with only 2 fractions in it. That means, notice when I move to the second fraction, to the second denominator, to make this denominator, 3 times 5, to make this, I need a 3. But in my pool of denominator factors, I already have a 3. So I'm not going to write that 3 down again because I already have a 3. I don't need another one. But I need a 5. So notice what happened here. Instead of multiplying 6 times 9, I'm really kind of only multiplying 6 times 5. And that's going to give me a much smaller denominator. And it's going to give me everything I need to do this problem. So this set of steps where you reduce or get rid of repeated factors, notice I just crossed off anything that repeated, and then I just wrote down what was left. So that means that my lowest common denominator is actually 30. 30 is a much nicer number to multiply with than whatever 15 times 6 is, which I think is 90. All right, so now let's go ahead and do that. Remember, whenever we start with 1/6 plus 2/15, this is right at the beginning. Now I'm just making this a problem that was like the problems we worked on just a little while ago. I have 1/6 plus 2/15. We have to ask ourselves, what did I multiply 6 by? What do I multiply 6 by to get 30? And if you're ever confused, notice 6 came from 2 times 3, which means I just have to multiply 6 times 5 to get 30. It's okay to do in the denominator as long as I do it in the numerator. Now let's move on to the next fraction. Take all my little notations out of here. So the next fraction has 3 times 5, or 15. 15 is 3 times 5. What do I have to multiply 15 by to get 30? That 2 right there. Now I can just do my arithmetic. 6 times 5 is 30. 5 times 1 is 5, plus 2 times 2 is 4. 15 times 2 is 30. Notice now I have a common denominator. I'm going to write 5 plus 4 over 30. and that's 9/30. And then I still have to reduce, and in fact, I'm going to reduce out that extra 3. So this equals 3/10. So 1/6 plus 2/15 equals 3/10. And your instincts would never have told you 3/10 for that fraction. Now, you're going to get a chance in class to practice this algorithm over and over and over. So I want you to be really careful to write this out exactly the way I've written it out, using all the same notations. These crossouts you don't have to write. These crossouts are only because on the computer you can't see if I put my finger over top of them. When you're working on your paper, you should just put your finger over top of the factors that you're trying not to look at to see what the multiplier you have to use in the denominator is.